Okay, lesson 7.2 is on two variable linear systems, and we're going to learn the method of elimination to solve the problem. 7.1, we learned substitution and graphical ways of solving it. So this is an elimination. What we're going to do with these two equations here, these two, we're going to add them together to eliminate the variable y. So 2x and 2x, we get 4x. And y minus y is 0. And 4 minus 1 is 3. So we can solve it for x by dividing both sides by 4. So x is equal to 3/4. And then you put that into either equation and solve for y. Now we can go ahead and put it in the second equation. So that's going to give us 2 times 3/4 minus y equals a -1. So if we add 1 and y to both sides, we have, and then multiply the 2 times the 3/4, that gives us 6/4 plus 1, and the 1 we're going to call it 4/4, so we can add them. 4/4, that's equal to y. So y is equal to 10/4, which is 5/2. And then finally, you're going to put the answer in a parentheses as a set. It's going to be 3/4, 5/2. So this is the solution. Now you would also want to put both of these into the first solution and solve it and make sure it works in both solutions. So if we put it in the top one, we have 2x. Again, we have the 6/4 plus 5/2. That would be 10/4. So 6/4 and 10/4 is 16/4, which is equal to 4. So it checks out. Okay, let's look at this first example. Solve the system of equations. So our two equations, we have 2x plus 3y equals 17. 5x minus y equals 17. Well, we can't just add them or subtract them and eliminate a variable. So what we're going to do is we're going to multiply the bottom equation by 3. And so that leaves us 15x minus 3y equals 68. 3 times 17. It's equal to 51. Now we're going to move the top equation over, keeping everything lined up. So we're just going to write a 2x plus 3y equals 17. Or you can keep them lined up. It makes it easier to add or subtract. So now we're going to add these two. So 2x and 15x, 17x. 3y minus 3y is 0. 17 and 51 is 68. So we divide by 17. That gives x is equal to 4. Put that into either equation. We'll put it into the second one. So 5 times 4 minus y equals 17. So 20 minus y equals 17. Gives y is equal to 3. And so then our answer is going to be 4, 3. Put a box around that. And also make sure it works in the first equation to check your answer. And then you're done. Okay, the next example. We have 3x plus 2y equals 7. And 2x plus 5y equals 1. Well, it doesn't look like an easy way. We can either try to eliminate the x or try to eliminate the y. But the way we're going to do this, and there isn't just one way, there's a number of ways. We're going to multiply the top one by 2. And we're going to multiply the bottom one by a -3. That way we can cancel out the x. So the top equation becomes 6x plus 4y equals 14. Bottom equation becomes minus 6x. And minus 3 times 5 minus 15y equals minus 3. So now we're going to add these. 6x minus 6x, 0. 4 minus 15y is minus 11y. And 14 minus 30 is 11. So that gives us y is equal to negative 1. Put that into either of the equations, and we get x equals 3. So our answer, 3, negative 1. And again, check it with both equations and make sure this is the correct answer. Okay, the next example, solve the system of equations. Well, it looks like first equation we have 6x minus 5y equals 3, and then a negative 12x plus 10y equals 5. So let's just multiply the top one by 2, and we'll add it to the bottom one. So this gives us 12x minus 10y equals 6. And then we'll bring over the second equation, minus 12x plus 10y equals 5. We're going to add these, and we have 0 plus 0 equals 11. Well, you may think this is not going to turn out very well. What this tells us is that this is no solution, because 0 cannot equal 11. But what it also means is these are parallel lines. So you could check it. They both have the same slope. So this is a no solution. Now, what if you get a problem that turns out 0 equals 0? Well, that's true. And what that means is you have an infinite number of solutions if you have a 0 equals 0. Okay, another example here. What if you have decimal coefficients? Well, it looks a little bit tricky using decimals, and so the easiest thing to do is just like multiply it by 10, because if you multiply each one by 10, you'll clear out all the decimals. So this is going to give 15x plus 8y equals 23. And the bottom one, multiplying by 10, gives you 3x minus 2y equals 1. And then you just solve this just like we solved previous equations. And okay, so now we're going to move on to a fun application problem. Okay, we have an airplane that is flying from point A to point B, and it's flying into a headwind. And the time it takes to fly from A to B in this headwind is 3 hours and 18 minutes. The return trip going from B to A takes 3 hours, and that way, and it has a tailwind at that point. So we need to find the speed of the plane and the speed of the wind if the distance from A to B is 1,650 miles. Okay, so the first thing that I like to do on these problems is just kind of sketch it out. So we have point A and we have point B. And the airplane is flying in this direction from A to B. It's 1,650 miles between the 2 points. And we know that it is flying into a headwind. So I'm going to draw the wind in this direction. We'll call it W. Okay, we'll call it W. And we'll call this P for plane. And this is going to be the rate, or we'll call it the speed. And P is the plane speed. Okay, and then the trip from B to A is just the reverse. The wind is still going in the same direction, though. Okay, so what we have is two unknowns, the wind speed and the plane speed. So that tells us we need two equations. Well, the overriding equation is distance is equal to rate times time. And so let's do from A to B, and we want the distance, which is 1650, is equal to the rate. So this is going to be the plane speed, and we're going to call that P. But the wind is going the opposite direction, so we'll have to subtract the wind speed. So that's the rate. And the time, it says, is 3 hours, 18 minutes. Well, the other time is 3 hours. We have to have the same units. So we could either make it all minutes or all hours. And to avoid a decimal, let's just make it all minutes. So 3 hours is 180 minutes and 18, so it's 198 minutes is the time. So that's one equation. Then B to A, we still have the same formula. Distance, which is 1650, is equal to the rate, which is, in this case, it's the plane speed plus, plus the wind speed. And the time for this is 3 hours, which is 180 minutes. So now we have two equations and two unknowns. What we're going to do is divide each one by the time. And so the A to B, we have 1650 divided by the time is 198. And that's equal to P minus W. And then the B to A, we have 1650 divided by 180 minutes. And that's equal to P plus W. And so now we have these in the form where we could just add them. And so we have 1650 over 198 plus 1650 over 180. That's equal to P plus P is 2P minus W plus W is 0. So now we can solve for P. And that turns out to be, so we divide everything by 2. P turns out to be 8.75. But the units of this are going to be miles per minute. That's not a very common unit for mileage or for speed. And so what we're going to do is multiply by 60 minutes per hour. Minutes cancel. That gives us 525 miles per hour. So this is the plane speed. Now we have to solve for the wind speed. Well, we can just substitute P into either equation, either here or here, doesn't matter. Substitute that in, and we get the wind is equal to 0.417 miles per minute. And again, multiply that by 60 minutes per hour. Minutes cancel, and we get 25 miles per hour. And that is the wind speed. So there's other kinds of problems that you solve like this. I think you'll have a boat in a river type problem. You may have another airplane problem. But these are, as long as you set it up, they're pretty easy to solve. Just set it up correctly, and there you go. So that's it for 7.2.